All right, good morning, everyone. This is Miss Trango. We're on section 11.5, volume of prisms and cylinders. So we're kind of switching gears after 11.4, which was kind of visualizing, representing the solids, and now we're getting into a little bit more computations, calculations, what a lot of people think of as traditional, more traditional math skills. Not that they both aren't. All right, our essential question, how do you find the volume of prisms, cylinders, similar figures, and composite figures? Our learning target, I can find the area of prisms, cylinders, similar figures, and composite figures. So the volume of a prism, here is the volume formula right here. V equals capital B, big B, times H. Please make sure you're putting a big B, and you really want to make sure it does explain here that big B is the area of the entire base, and the height is the height of the shape. So for example, if I was finding the volume of this rectangular prism right here, I'm just going to make up some numbers. Let's say that it was a square base that was 2 by 2. Capital B would be 4 because the area of that whole square is 4. And then let's just say my height was 20. It's kind of tall. So how would I find the volume? 4 times 20, 80. Whatever, units squared. So just make sure that you're really realizing this is a common issue that I find with students. Capital B is the area of the base, not just like the length of the base. Height should always be perpendicular to the base. So if your figure is slanted like this one, the height is the distance from the top of your figure the height is the distance between the two bases with a perpendicular line segment, so it would not necessarily be the length of this, if that makes sense. So make sure you have this formula and that you understand that B is the area of the entire base. Here it is. All right, so cylinder. Cylinder is actually pretty similar to a prism. That's why they're both in section 10.5. So typically, I mean, you can use your notes, so it's not a huge deal, but the formula sheet in Minnesota for the volume, I put a box around it, looks like this. V equals B times H, and that is the formula. They also wrote out here, since the base of a cylinder is always a circle, and the area of a circle is pi r squared, another way you could write it is pi r squared times H. Those are the same thing because the base is a circle and the area of a circle is pi r squared. Similar figures, you'll notice there's like a little bit of a green thing over here, so leave a little space in your notes. We're going to go through some of the examples, and we will come back to this slide, to page 2, to go over that. Right here, to similar solids, this place that we skipped and I said we'd come back. Maybe you were hoping I'd forget. But the volume of similar figures, the volume is k to the third times bigger. All right, so make sure you put that in there. All right, so let's work through a few of these using our volume formulas. Find the volume of each prism. How do I know these are prisms? They have two bases. Part A, there's two triangular bases. So volume is base times height, capital B, base times height. This is the way I do this process. I ask myself, what shape is the base? What shape is the base? Hopefully you're saying triangle. The shape of the base is a triangle. How do you find the area of a triangle? 1/2 base times height. So that whole B can be written as 1/2 B times base times height. Don't forget you still have this H at the end. This H that I wrote in black, this is the height of the whole prism. All right, so let's plug some stuff in. So that red part, I'll keep it in red, is just the triangle. So the base and the height of my triangle is 3 by 4. So 1/2, 3 times 4. And then the big H, although it's actually smaller in this case, the big H of the prism that connects the two bases is 2. You can plug that whole thing into your calculator. You can do it in your head, however you want to do it. You should be getting 12 centimeters cubed. And volume, three-dimensional volume, is the space inside a figure. I don't know if I said that. Volume is the space inside a figure. It's measured in three-dimensional units, so centimeters cubed. All right, this is also a prism. It has two bases, so I'm still doing base times height. If I think about my base is a quadrilateral, and it looks to me like a trapezoid. The base is a trapezoid. You may have forgotten, it's been a while since we talked about a trapezoid. The area formula for a trapezoid is 1/2 B1 plus B2 times H. So that whole thing is my big capital B. So volume equals, I'll use red for that, 1/2. You add your two bases times the height. Then don't forget you still have the height of the entire prism. So let's start plugging some numbers in for that. So 1/2, my two bases of the trapezoid, the top base is 6 right here. The bottom base is 14, so 6 plus 14. The height of my trapezoid right here is 3. And then the big height from base to base of my prism is 5. You can plug this whole thing into your calculator. You can do it in your head, however you want to do it. I'm getting 150 cubic centimeters. So make sure you're finding the area of the base, and then you are multiplying times the height of the prism. All right, now we're going to look at cylinders. So cylinders are same formula, base times height. Remember, the base is a circle. The area of a circle, the formula for that is pi r squared. So here, my base, I'm going to change that to pi r squared. And if I look here, the radius is 9. So pi times 9 squared. The height from base to base is 6. So sometimes we'll leave the answer in terms of pi, like we'll do 9 squared, 81 times 6. Sometimes you'll multiply it all out. If I do that, I'm getting 1,526.81 cubic feet. This is a pretty big cylinder. Maybe it's like a food storage cylinder, something like that. You might want to just pause the video and try part B on your own, see what you get. Okay, so you may want to try this on your own, see what you get. Here's how I set it up. Pi r squared, 4 squared, you could put a 16. The height is 7. Type that all in. I got 351.86 centimeters cubed. All right, number 3, kind of getting into Mr. Dowd's territory, density, science here. What do you need to write down? Probably just this. Density is the mass divided by the volume, okay? So density, is kind of, I think of it as, okay. So density is the mass divided by the volume. So I usually think about density as kind of how condensed something is. I think of myself as a dense person. I'm not super tall. Well, I think I'm tall, 5'4". But, I have a lot of mass in a small volume, very strong person, I like to think. So I'm a dense person. Anyway, different materials have different densities. Salt, sugar, things like that. That's why some metals, gold, etc., might be heavier versus lighter or feel that way. Anyway, okay, the diagram here shows the dimensions of a standard gold bar at Fort Knox. Gold has a density of 19.3 grams per cubic centimeter. Find the mass of a standard gold bar to the nearest gram. So remember, density, I'm going to use just a D for that. I'm just going to abbreviate. Density is mass divided by volume. So they told us right over here the density is 19.3. So I'm going to fill that in for my D. Density is 19.3. We are trying to find, I kind of wrote over it, but it says find the mass. I'm trying to find M. The volume, we can calculate. This is actually a rectangular prism, base times height. My base right here is going to be 1.75 times 3.625 times 7. And really, it doesn't matter the order and how you think about it. Like if you considered this the base and then this the height or vice versa, you're going to get the same volume because of the commutative property. So the volume is going to be 44.41 cubic inches no matter how you do that. That is going to get plugged in to V right here, 44.41. Now to solve for M, I have an equation, I have a fraction. A fraction is division. To get rid of a fraction, to undo division, I multiply on both sides. So basically I am doing 44.41 times 19.3. I am getting 857.11 for the mass. So definite grams, and this is in grams. So please let me know too if you ever see any mistakes in these.